Welcome to 7-4, Solving Inequalities by Adding or Subtracting. Our objective today is to add and subtract inequalities using the add-subtraction property that we learned for equations. Let's take a look at our first problem. The directions say solve, check your solution. We have had these directions before. What's different is that this is a inequality. X plus 3 is greater than 10. All right, what is the difference? Once again, it's this sign right here that is the inequality. I just ask you to remember that we can treat it just like an equation. So what we're going to do is we're still going to isolate the x. We're going to still use reverse PEMDAS. So here we go. I'm going to isolate the x, so I want to subtract 3 from both sides. I get x is greater than 7, and I do believe that's my answer. In order to make sure that this is the answer, I am going to check my solution. If you look at the answer, x can be any number greater than 7. So when I check my solution and I pick an x to plug in and determine if it's true, my x has to be larger than 7, can't be equal to 7, and can't be less than 7. Right now I'm just going to pick x is equal to 10. I think 10 is easy to work with. That's one of the main reasons why I'm picking it. I'm going to go back to the original problem. I'm going to substitute x into 10. Alright, so now I'm going to go ahead and add 10 plus 3. I get 13. Is 13 greater than 10? That is a true answer. So I feel pretty confident that x is any number greater than 7. Right on this slide, we still have the same directions. Solve, check your solution. Then we have another inequality. It says negative 6 is greater than or equal to n minus 5. So let's isolate the variable n by adding 5 to both sides. I get a negative 1 is greater than or equal to n. All right, before I commit to this answer, I need to rewrite this answer in the correct format. And the format is, I want to do the variable first, then my inequality, and then my answer. So what am I going to do here? I'm going to reverse or flip my answer. Well, I'm going to put the variable here. My answer is negative 1. And since I flipped the n and the negative 1, I also have to flip my inequality. That is the answer in the correct format. Let's continue on to our second part. Check your solution. Once again, my answer says that n has to be less than or equal to negative 1. I need to pick an n that's less than negative 1. I am just going to go ahead and pick negative 5 because negative 5 is less than negative 1. I think it's easy to work with. That's one of the reasons why I chose it. So I'm going to go ahead and plug it in. Negative 6 is greater than or equal to. Now n is negative 5 because that's what I chose it to be. I have now negative 6 is greater than or equal to, and when I combine these two together I get negative 10. Is this statement true? Is negative 6 greater than or equal to negative 10? It's certainly not equal to, but it is greater than. Therefore the statement is true, so therefore I am pretty sure that is the correct answer. Right on this slide we have solve. And the second part we need to do is graph the solution on the number line. Reviewing once again, we use the inequality like an equal sign. It divides our problem into a left side and a right side. Just like a equation, we're going to isolate the variable, so I'm going to do reverse PEMDAS. I am going to subtract a half from both sides. That cancels out and leaves the a isolated on the left side. My sign stays the same. I then subtract half from a 2, I get 1.5. Now I'm going to check my format to make sure it's correct. I have my variable, I have my inequality, and I have my answer. Alright, so now that I have my answer in the right format, it is going to make graphing easier. Alright, here's my number line. It's got enough information for me to graph my answer. I am going to put a circle where 1.5 is, and I got 2 circles to choose from. One is an open, and the other is a closed. Open corresponds to greater than or less than signs, where my answer starts but does not include that number. My greater than or equal to or less than or equal to are the closed dots, and that says include that number. Since our answer is a less than sign, I am going to go ahead and find out where 1.5 is, put an open circle. Now I'm going to go back to my format, and if you notice that the less than sign makes an arrow that tells me that I need to go to the left to represent all the numbers less than a half. I'm going to go ahead and shade that. And you can see our graph now has an arrow pointing to the left, kind of resembling our less than sign. And all the answers are to the left of the open circle at 1.5. In this slide we have a word problem. Antonio has $18 to ride go-karts and play games at the state fair. If the go-kart costs $5.50, what is the most he can spend on games? Well, let's talk about this. We know he's going to ride the go-kart, so that price is definitely $5.50. We're also going to have another expense we're going to add together, and that's N. And N represents, of course, the cost of the games. We know that Antonio only has $18. So when you're spending money, you can never spend more than, you have to spend less than what you have. But he can go all the way up to 18, so that means it can be equal to 18. Now that we have written our inequality, let's solve for what the cost of the games can be. So the first thing I'm going to do is I'm going to isolate the n by getting rid of the $5.50 from both sides. Remember that the inequality sign divides it left and right side. Now I have n is less than or equal to the difference of 18, and $5.50 is $12.50. So we now know that Antonio can spend up to $12.50 on games. He can't go over it, but he can be under it.